Hello everyone. We are presenting a final project titled Root Pulse, the FoodRunner. This is a mobile application built using Flutter and Firebase where we have integrated Firebase authentication, the Firestore, the storage, and the cloud messaging. In this project, we focus on solving the real world food delivery problems by building a system that connects customers, restaurants, and drivers in one unified platform. So, coming to the, can you change the slide?
Yeah,
Yeah. The problem. So, the main problem we are solving is fragmented communication in food delivery systems. Right now, customers, restaurants, and drivers often operate in disconnected systems, which leads to delayed deliveries, poor tracking, confusion like where is my driver? And all these problems are commonly faced. So, the main our target users are the customers ordering food, the restaurant operators who manage the orders, and the delivery drivers handling the logistics. Our solution creates one synchronized workflow where everything is transparent, especially order status and driver assignment. Coming to the objectives, our project is built around five key objectives. First, we implemented role based accounts for customers, restaurants, and drivers. Second, we created a real time order lifecycle using Firestore. Thirdly, we designed an assignment module that scores drivers and assigns orders efficiently. Fourthly, we provide live visibility, including tracking and explanation of how drivers are selected. And finally, we fully integrated the Firebase services, including authentication, Firestore, storage, and cloud messaging. And each of these objectives is demonstrated in our application. Coming to the inputs and outputs, now focusing on the core assignment module. So the system takes three main inputs: driver GPS location and availability status, and the restaurant location, the order urgency, which is calculated during the checkout. Based on these inputs, the system produces a ranked list of drivers with scores and offers sent to the best driver, real time UI updates using Firestore listeners. This ensures the assignment process is both efficient and transparent. High level solution for this, as shown in the diagram on the slide, the system is designed as a thin client architecture. The Flutter app handles the UI for customers, restaurants, and drivers. And the Firebase acts as the backend where the Firestore stores all the data. Authentication manages the users. The storage handles images and proof of delivery. And FCM sends notifications. So essentially, Flutter listens to Firebase in real time and updates the UI instantly. Here's how the user flow works. For customers, they go from discovering food to selecting the menu, and then they check out, and then it goes to the tracking. For restaurants, they confirm the orders, prepare the food, and dispatch. And for the drivers, they receive offers, they accept and deliver, upload the proof, and complete the order. Also, some screens show empty states initially, which is intentional since this is a multi role system. Coming to the Firestore data model, as shown in the table on page 3, our Firestore database is structured into collections: the users, restaurants, menu items, and orders, and reviews. So the users are here to store the profile, the roles, and driver status. And the restaurant stores location and ownership info. The menu items are linked to the restaurants, and the orders includes order details, status, and driver assignment. The reviews will contain the optional feedback after delivery. One key design choice is that drivers are stored as users with a role, which simplifies queries and security rules. The remaining part will be continued by my teammate.
Hello everyone, I'm Sattwik, and I'll start with the architecture decisions. So we made several important design decisions. We used Flutter with Provider for state management, allowing shared data like cart across screens. We also implemented a repository pattern so business logic like assignment is separate and testable. We also designed the system to scale with features like geohash filtering, transaction-based assignment, and also real-time map tracking. So real-time map updates come from Firestore streams, not constant GPS polling. Moving on to the logic. So this is the core logic of our system. So now for each driver, we calculate a score based on three factors mainly. First is the distance to the restaurant, second is the order urgency, and the third is the driver availability status. So we used weighted scoring, for example, like distance 45%, urgency 35%, and status is 20%. Drivers are then sorted based on this score, and the top driver gets the offer. And if no drivers available, then the system falls back and includes busy drivers. Now, this logic is mostly implemented in our assignment engine Dart file and is fully testable. Now, talking about the Firebase integration, now we integrated multiple Firebase services. The first one is the authentication for login and role management. Second is Firestore for real-time database updates. Third is storage for images and delivery proof. And the fourth is the FCM for push notifications, which Abhinaya mentioned earlier, all of these. Now we Now we used Firestore snapshots to ensure real-time updates across all users. Now this is what exactly enables live tracking and instant UI updates. Moving on to the testing and validation. So our testing strategy includes first the unit testing for the assignment logic, widget testing for UI, and end-to-end manual testing across all roles. Um, and then we, for example, we tested that closer drivers rank higher. We verified also the fallback when only drivers are available. We also fixed issues like state management bugs in cart controller, driver status clarity in the UI. All these tests are basically included in our project. Now, talking about the team contributions, our team contributions were divided as follows, like Abhinaya focused on the customer experience, UI design, and the tracking, and also the documentation, whereas I worked on the Firebase integration, assignment engine, driver and restaurant flows, also the testing and backend logic. Both of us collaborated and on the debugging and final integration as well. So yeah, so mm, we've this is the summary to our project. Our like the first is the assignment logic implementation, then the Firestore, which writes operations for dispatch, and the real-time listeners, transaction handling for accepting orders. So to summarize, we successfully built a three-role food delivery system with real-time tracking, intelligent driver assignment, Firebase integration, and for the future improvements, we could include like geohash optimization, map-based live tracking, and a more robust transaction handling. Thank you for your time. And yeah, this is our project. Thank you. Psst, a second. Sorry. I'm sorry.
The recording is not stopped.
Yeah, I know. Just a second.